Hey everybody. Today we're going to be taking a look at a new type of function. It's called a radical function, and we're going to take a look at the graph. This is my parent function for a radical function. So f of x equals the square root of x. You're probably more familiar calling this a square root, but it's called a radical. And I could change the number that's on the outside that we'll get to tomorrow. But for today, we're just going to take a look at the graphs and see what the graphs look like, and then take a look at transformations. So this is my most basic one. So f of x equals the square root of x, which is the same as y equals the square root of x. So if I look at that in Desmos, which I've already pulled up here, this is my most basic square root function. Let me make it a little bigger for us here. So it starts at the origin, and then it kind of, I guess you could think, kind of curves up, kind of escalates. But this is the general shape for a radical function. So the general shape for a radical function looks just like this. So this is my most basic one. I've already labeled the domain and the range. So the domain is anything greater than 0. So I can see here on the right-hand side where Desmos is still peeking out, your x is not going to get past the y-axis. So it starts here at 0, 0, and it's everything to the right where my pointer is moving at. So my domain starts at 0 and it goes to infinity. You can write it as x is greater than or equal to 0, or you can write it in set notation. It goes from 0 to infinity. Both of those say the exact same thing. Now, if I take a look at the range, y is greater than or equal to 0 or 0 to infinity. They say the same thing. Again, over here, looking at my picture in Desmos, it starts here at 0, and then it does not get below this point. So all my x's and all my y's are positive numbers. That's why my domain and the range is anything greater than or equal to 0. So you can write it as an inequality, or you can write it with the brackets and parentheses. It goes from 0 to infinity. So this is the most basic one. Today we're going to take a look at the transformations. So I have a whole bunch already listed there, and we'll go through and I'll go through and write the answers and stuff down for us so that you can get a better sense of how to take this parent function and flip it, move it, stretch it, shrink it, and all that good stuff. So the directions over here say, describe the transformation from f of x equals the square root of x. So this is going to be my most basic one that I'm going to keep in Desmos. I'm not going to change it. And we're going to go through several examples and see what effect putting a number on the outside or the inside, positive, negative. We're going to see what kind of an effect makes on my graph. So let's start with the first one. So I'm gonna keep this one in here the whole time. This is my parent function. All right, let's take a look and see what happens when I do 4 times the square root of x. So 4 times that square root of x is a vertical stretch by 4. So notice it's taller, so to speak. Again, kind of think of a rubber band stretching out. So this is a vertical stretch. So the first one is a vertical stretch. And I'll be moving back and forth so that you can see the answers at the very end. And I'll also be saying them out loud for those of you that are taking notes. So the first one is a vertical stretch. So let's see what else happens. Let's see if I do 1/4 times the square root of x. Notice that one shrunk. So this one is a vertical shrink. All right, vertical shrink. So the take-home point here is that if you have a number on the outside, if that number is bigger than 1, it's a vertical stretch. The number on the outside, if it's between 0 and 1, it's a vertical shrink. So that's the take-home point for this section right here. Number in the front is going to be a vertical stretch. Number between 0 and 1 is going to be a vertical shrink. So let me get rid of these, and then we'll keep right on going and see what else we can do. All right, now let's see what if we put a negative. So notice I put a negative in front of the square root, in front of the radical. This is a reflection over the x-axis. So this one reflects over x-axis. So that's the answer to that one, is a reflection over the x-axis. Okay, so that's it for that one there. So it's a reflect. If you have a negative in the front, it reflects over the x-axis. All right, so let's see what happens. So this time I have the square root of x plus 7, and the plus 7 is inside of my square root. So we started here at the origin with the basic one, and then we moved over left 7 spaces. So if you have a number inside the square root, it's going to move it left or right. Particularly, this moves left 7. So hopefully you can go ahead and hypothesize here. If it's x minus 3 inside the square root, that moves right 3 spaces. So this one moves right 3 spaces. All right, so let me get rid of those. Those are my transformations there. Again, very straightforward. You can keep your parent graph in the Desmos as you're working so you can compare and contrast and make sure you're being specific with what is happening. Okay, let's take a look at the square root of x plus 2. So this is my parent graph. Let's pop this one in. Okay, so now I'm looking at the one in the green. So if I'm looking at the one in the green, it moved up 2 spaces. So a number on the outside moves it up 2 spaces. So you probably can deduct that if it's a negative here, it moves down 5 spaces. So number 7 moves down 5. So parent function is the one in the red, the green moved up 2, and the purple moved down 5. Okay, let's see what happens if I add a number right in front of the x, but it's underneath the square root. So from the red to the black. So let's try that again. This is my parent function. And then notice what happens when I do 1/2 x inside of the square root. So it kind of got down a little bit, kind of shrunk down a little bit, but this is actually not really a shrink. Well, it's a shrink vertically, but we're going to put this in terms of horizontal. This is actually a horizontal stretch. So if you can imagine pulling sideways, so making it elongated sideways. So this is a horizontal stretch. So horizontal stretch. So likewise, this one is going to be a horizontal shrink. So the one in the blue that I just put in, the square root of 2, that number in the front there, that's going to be a horizontal shrink. And the last one that I want to put in here, number 10. So let me get rid of those. So if you have a number on the inside in front of your x, if that number is between 0 and 1, it's going to be a horizontal stretch. And if you have a number in the front that's greater than 1, that is going to be a horizontal shrink. So the last one that we have, let's take a look and see if I have a negative on the inside. So this negative on the inside is a reflection across the y-axis. So the red one is my parent graph. I pop the green one in. It is a reflection over the y-axis. So reflects over y-axis. So these are all of my reflection rules. I simply typed in the parent function into Desmos. There you have it for those of you that have been following along. So I typed in the parent function in Desmos, so f of x equals the square root of x. And now we can go through and see what the numbers mean and what kind of effect it has on the graph. So in summary, a number in the front is going to be a vertical stretch or shrink. If it's negative in the front, it flips over the x-axis. If it's negative inside the square root, like number 10, it flips over the y-axis. If you have a number inside of the square root, it moves it left or right, and it's the opposite of what you think. If you have a number on the outside, it moves it up or down. Then if you have a different coefficient underneath the square root, it's going to be a horizontal stretch or a horizontal shrink. Now, hopefully you already figured out these are exactly the same transformations that we've done for all the other functions. Rational, quadratics, different polynomials, absolute value, because these are the same transformations. So regardless of your function, the position of the number is going to have the same effect on the graph. But if you haven't picked up on that pattern yet, you have your Desmos to help you. You can type in the parent function. You're going to have to know what your most basic function is. So you can type that in and then type in what they're giving you so you can make it move left, right, up, down, stretch, flip it, reverse it, and all that good stuff.